All right, 1.3, we're combining transformations here. So we've talked a lot about translations. Remember, translations are just movements left, right, or up and down. And the translations do not involve any kind of stretching or warping or squishing, right, of the actual graph. It's the exact same graph, it's just moved left or right or up or down. Now we talked about A and B as well, and those are the ones that can actually warp the graph. They can actually stretch it horizontally or compress it in horizontally. It can stretch vertically or compress vertically. So we can put all of these together, and we have the 4 parameters that can change a function. Okay, so what I want you to do is I want you just to rough sketch this W here, okay, and make it as close to this as you can that you see on the board here, because we're going to be doing some transformations on this. This is our random y equals f of x graph, okay? Maybe I'll just zoom out just a bit there. I know that's a bit smaller. Hopefully you can see that. While you're doing that, let's just remind ourselves that the h is a horizontal translation. And you know what I'm going to do? I'm going to build this. Here's our f, y equals f of x, okay, the blue. So the h is our horizontal translation. And we see the h, oops, I'm going to use a different color here. We see the h as a parameter. There we go. We see the h right there, okay? So the h moves the graph left or right. That's where the h is. The vertical translation is the k, which is outside of kind of the base function, and the k is out here. The a is pretty easy. That one we've dealt with for a long time, and that is simply the number that is multiplied by the function. It's on the outside of the function, multiplied. The b is inside with the x. Now let's be very careful here. I don't know if you've noticed this before, but the b is multiplied by the x, but in order for this h to still be the h, we have to put brackets here, a secondary set of brackets. Okay, and I will explain this more as we move through, okay? So the h here has to be inside with the x, and the b is technically distributed to the h as well. So that's a little bit tricky. We'll come across that in a bit. All right, so let's say we actually have a function that looks like this. It's going to be transformed using these values on the right. So where do I put those? Well, it looks like this. I'm going to have a 2 as an a value. The b value is going to be 3 inside here with the x. I'm going to put those secondary set of brackets there. The h is 0, so I subtract 0 inside those brackets. Close with the second set of brackets there. And then plus 2 on the outside. Okay? So you can see the a, the b, the h, and the k there. All right. So combining transformations, the easiest way to do this is to work really from left to right as you do each individual translation. So I would suggest that you do that. You take the graph and you start at the very left with the stretches, okay? So notice that these can be separated as stretches. The a and b are stretches, and the h and the k are just translations. So if we do the stretches first, that's going to be the best way to do this. So we'll focus on A, and then we'll focus on B. So let's do one thing at a time. So you're going to have 3 or 4 different graphs superimposed on this. So I hope you made it like a little bit big enough. And you might want to use a pencil. If you've used a pen before, you might want to use a pencil, because we're going to be drawing each individual stage of this transformation. So let's take a look at the vertical stretch phase first, or stage. So every point, and we'll just pick obviously some of these important points right here that are on the graph, so just the corners of the W. So each of those y values of these points have to be multiplied by 2, right? Y value times 2 for every point. That's what this A means. So this point is a 4. It's going to go up to an 8. A 0, well, that's the y value here, is going to stay 0. Because remember, 0 times 2 is still 0. This 2, it's a y value of 2 for this point right here, and this is a 4, so that goes there. 0, and this y value of 4 gets multiplied by 2 to make 8. So this stretch alone, and we should know this stretch alone looks like this, and this is going to be a terrible kind of dashed line, but this is what the new transformation looks like with just the a alone. So that's step A. That's the first step. So B now, okay. So B affects the x values, right? B affects the x values. And do I stretch out with a b value of 3, or do I stretch in with a b value of 3? In. I saw some nods for in. That's exactly correct. So x values are going to be times 1 over 3. Okay, so the x value is divided by 3. So the next stage, I'll do this in blue here. Okay, this is going to be blue. Now this is where it's going to get a little bit busy here. Okay, but the x value of 2 divided by 3, that's going to be at 2/3. So this one moves over to here. Okay, so the new points move over to in 1/3. So this one moves over to 2 over 3. So at x equals 2/3. This one, negative 2/3, so it's going to be squished in a little bit. And I'm going to zoom in here. Okay, I'm going to zoom in here a little bit. Oh, did not mean to do that. Okay. All right, so this point is times 1/3, so that's 2/3. So that's going to be right about there. This is the new point right here, the one here. So times 1/3. What is x equals 6 times 1/3? That's 6 over 3 is 2. So it comes to there. Again, everything is being compressed by a value of 1/3, the factor. So this one comes to negative 2 as well, compressed by a factor of 1/3. So in blue now, this is what I have. And of course, this point right here is 0, so it doesn't get changed. 0 times 1/3. So this is like this. There, up to here, down to there, up to here. Now, because I'm going to erase some things here because it's getting pretty busy, but hopefully you can see that this blue dashed graph now is
Wait,
one.
Does it go to the 4 or the 2?
What?
On the x-axis. I mean on the y-axis.
No, this is coming onto the new one. Like this. So this was stage 1,
I mean
This-
like
and then this is stage 2. So this point has stretched up a value, and then 1 over b to get to this point. So if you want to follow one point here, that's great.
no, I mean the middle one.
The middle one, yeah, okay. So what's the x value for this middle point?
Well, shouldn't it be 2 because that was the original function?
No, the original function went to 4 because we multiplied everything by 2. So the original y value was 2, yeah, and then we multiplied by 2 to get 4. Now we're dealing with the x values, which the x value for this point right here is 0. So 0 times 1/3 is still 0, so that one stays. Yeah, another question?
Just to be clear, it's
Yeah.
possible for you to start like graphing the b value first and then the a value?
Yes,
Right.
good question. You can do the b transformation before the a transformation if you want. Best to do the stretches first, and just to keep it simple, I always say start with a, then do b, then do h, then do k. Work left to right. You'll never be confused. But yeah, you could do b first and then a. Totally fine.
Curious.
Yeah, totally fine. All right, so now the stretches are done. The nice thing about this, having the stretches done, is that we can now just easily move left to right, up and down, and the shape now doesn't change, okay? So I'm going to erase the black one, this black graph here. I'm just going to get rid of that because I don't want it to be just too crazy busy here. Okay, so we've got the blue graph, and now what's our Oh, our h value is 0. So guess what? We don't have to move it left or right any units at all. 0 units. So left or right is out of the picture. Now what I need to do is move everything up 2 units. So let's get zoomed back in here. And if I move everything up 2 units, I'm definitely going to run out of space here, but let's do it in, can you guys see the yellow all right? Can you guys see that? See what? Yeah, okay, so that's a no. All right, let's do red. Okay, so this point is at 8, so it's going to go up to 10. I'm off my graph here, but that's fine. 8 to 10, those go up there. This 4 goes to 6. This 0 right here goes to 2. So that's going to be careful with that one because it's over 2/3 and up. So now it's going to go up 2. So this blue dashed graph is simply moved up 2 units. So it looks just like this. I know that's very difficult to see probably from the back there, but that blue graph has moved up 2 units. So if we were counting look at this point, let's follow this point again. So we've got a equals 2, so that's times 2. We've got b equals 3, so that's divided by 3 to get here. And then k is 2, so that goes 2 units up. That's the third and final stage that we did. H was 0, right? So guess what? Our new point, and this is actually pretty important, the original point was 6, 4. You see that? Our new point after these transformations is what? Well, no, it's actually got to go 2 over first. 2, 10. 2, 10. Okay? That make sense? And so that kind of leads us back into mapping notation. So we can go from original point to new point using the mapping notation. So let's work on that mapping notation for this one. Now, do I have that down here? Yeah, actually I do have that down here. Let me just bring that up. Just bring that up. And all right. So 1/3 x. Now remember we did every x value times 1/3. So this is your mapping notation. That's a bx. So every x value got multiplied by 1/3. Let's see if that works. We started with 6, 4, and we went to 2, 10, right up there. So did that work? 6 divided by 3 is 2. Yes, that worked. The other thing we did was we multiplied every y value by 2. So that's why we have a 2 in front of the y. And then we also added 2 because we moved it up. So if we go 4 times 2 plus 2, that equals 8 plus 2 is 10. And that's what we see there. So this mapping notation, you can take any individual point using the mapping notation and you can get its corresponding point, which sometimes will be very helpful. Okay, so that's the mapping notation. While we're on that vein here, this is the general format for mapping notation. I don't know if I've given you this in a previous lesson already, but you may as well write that down. So the original function has just a point, any point on the original function of x, y. The mapping notation will transform this point, x, y, into the new point by doing 1 over b that's a b there, that's not a 6, that's a 1 over b times x plus h. That gives your new x value. And the y value, you multiply the original y value times a, and then you add k to that. And that's how you get your corresponding point. So that should work for any point on the above graph here. We could do that and take a look at any point. We just did that one example. Okay, any questions there so far? All right, I'm just gonna give you let's say we have some random really weird function like this. Okay, you don't have to draw this down. You don't have to write this down. But let me just see if I can do this. So I am going to, on my screen, I'm going to try and just highlight, or just select, okay, the graph. Okay, good. So here is the graph. I've got a copy here. My only problem is I won't be able to select just one. Okay, so let's say that we have a transformation, and this transformation, it just goes down k units. That's what the new one would look like, right? Just go down. If the original transformation just had a h value, and it was, let's say, whoops, come on now. If it was x minus h, I would move the new graph to the right h units. That makes sense? So a combination of those two would be right and maybe down. There's your new one. Now the stretches. Okay, so here we go. I'm going to try and do this. So the original graph, where's my x value? Okay, here we go. Watch this. So that would be, because it reaches below the x-axis and above the x-axis, some of it goes, and you guys have already come into contact with this. Let's change the pen properties here. Let's make it black. So look at this. This is an intercept, so that doesn't change. But if this was like a y value of 1, let's say, we multiplied by 2, it would go up. If this was a negative 2, or if this was a negative 2, we multiply it by 2, it would be a negative 4 down here, you see? So above the x-axis would stretch up, below the x-axis would stretch down. It always stretches away from either the x-axis or the y-axis. So in this case, an A would stretch away from the x-axis.
Yeah, like if A is positive, right?
Yes. If A was negative, it would be flipped and then stretched. If it was negative 2, let's say, flipped first, which I can't really do with this, but you could flip it first and then stretch it. Okay, so here's the other thing. Now watch this. Let's say we have a B value of 3. So I'm going to stretch everything by a third. And so it's going to stretch out. But I have to be careful because we're going towards, no, if B was, oh, sorry, yeah, you're right. I stretched it out. Let's say B was 1/3. Let's do that because we haven't done that one yet. B was 1/3. Then everything would have to stretch out by a third. I'm just trying to get my bearings here. Yeah, this is a little bit tough. Okay, so it doesn't go up or down, but now, okay, let's try that one. So if B was 1/3, B equals 1/3, then it's times 3 in a horizontal direction. So that means that this would go times 3, this would go times 3, this point would go times 3, this point would go times 3, and so on. Everything, and then this way, this point would go times 3. I think I did my A value and my B value here. But this would go times 3 out, and times 3 out, and so on. Everything would go out. So this is a bit of a combination here of A and B, really. Okay, so the example breaks down with this technology that I have, but okay. So something like this would be a stretch up and a stretch, horizontal stretch out. So stretch A value and then a horizontal stretch out. Question?
So with stretches, does the y-axis never change?
Well, okay, with stretches, does the y-axis never change? If it's an A value, then it will go up the y-axis or down the y-axis. Yeah, that will change. If it's a horizontal stretch, though, anything that's on the y-axis would not change because it'd be like 0 times whatever. So it wouldn't stretch horizontally, the points on the y-axis, but points on the y-axis would stretch vertically with an A value. So it depends. All right, let's take a look at this one, and something happened here. What happened here? This went down. Okay. All right. So take a moment to just to rough sketch this one in your book as well. Okay. Let's do another example here. So here's your given graph, and it's kind of like this is like a square root graph or whatever. You don't need to know that now, but here are the important points. And again, you can just kind of rough sketch those. and we'll do some transformations on those. So take a minute. So this new graph, we want to graph this graph, okay? So here's y equals f of x in blue, and I want to graph this one. Now let's identify first of all from the equation what a, b, h, and k are, okay? And here's where we're going to have to be kind of careful with b, but what's a? Is there anything here? Okay, so a is 1, right? Thank you for not saying 0, because that would make all of this 0 gone. So it's not 0, but it is 1, correct? A is 1. What's b? B is pretty easy to see. It is 2. Okay. So here's where you have to be careful inside the brackets here. Remember I was kind of like sticky about those double brackets? So you have to factor the b out from the x here, which actually makes this factored form of this 2 times x minus 3. Okay? That's the tricky part. And remember, if we want to use this format of a, b, h, and k, we do have to factor this inside the brackets. If it's not factored, we have to factor it. That's pretty ugly. Let me try it again. Okay, everybody see that? So b is 2, but h is? H is? Well, h is actually, technically it's positive 3 because the format is x minus. So it's technically positive 3. Yeah. But you're right, it shows up as a minus, which we know moves it right. But see, because h is a positive 3, that's really why it's moved right. H is positive. It shows up as a negative inside the equation though. So h is technically 3. And then, of course, k is 1, plus 1. Okay. All right, so this is what I'm going to do with my fancy dancy technology here is I'm going to trace this line. Okay. And then I am going to apply the first transformation. So let's do A. What are all the y values listed on these points here? Times 1. The new y values are the exact same. So A equals 1 does not change the graph at all. Okay, every y value on the point times 1, those are your new points. Okay, great, they're the exact same. Let's move to B. Okay, so B is 2, so is the graph going to stretch out wider or get crunched in, compressed a bit? Yeah, it's going to get crushed in a bit by a factor of 2. No, not wider, it's going to go in narrower because it's a B. So it's going to be compressed by a factor of 1 over 2. So let's see if I can do this. B is horizontal. Okay, so 9. I'm looking at this top point here. 9 goes to about 4.5. So if I did this right, the 4 times 1/2 should be 2. That looks like a 2 there. The 1 here, remember we're dealing with the x values, should be going to 1/2. That looks about right. And 0 times 1/2 is still 0. So this is my first stretch. And I'll change that to, let's say, purple. It's just a little bit different than the blue. Okay. Everyone okay with that? You see that? And you can just take literally every point and divide it by 2. Divided by 2. This one divided by 2 over here. This one divided by 2, so on. Okay, now we're done with the stretches, so that's great. So now you can just take that graph and you're just literally moving points left or right, up, down. It's the same shape now. So this is the new shape. We're just going to deal with this shape. So I'm going to just copy this again, and I'm going to now move it. Where do I move it? What's next? H is 3, so which way? Over 3 to the? To the right, that is correctly. So there's 1, there's 2, and here is 3. Should be right there. See how accurate that is. Okay? So every point moves over 3 units to get this new one. And what I'll do for you here is, draw the one that I just had because it's tough to see where it came from. But this is sort of what it was like. Right? Just like that. And I moved everything over 3 units. 3 units, 3 units, 3 units. Okay? And then finally k is 1, so let's grab this. Again, you always kind of move from the last one you just did, you always kind of work A, B, H, K, and you just keep working on the same graph. So now we're going to go up 1 unit. Whoops.
To the senior girls and senior boys, please make your way down to the gym. Please be dressed in your uniforms.
Okay, so this is our final version of this transformation. All right? Any questions?
Does it have to go up 1 or 1 squared?
Well, it goes up 1 unit. Oh, yeah, I gotcha. Yeah, this scale and the scale is actually. You're right. You're right. So this goes up 1 unit, which is actually in this one 2 squares. There we go. So that's what it looks like in the end. So just a reminder, the A value is the vertical stretch. Everything gets multiplied by A. Every Y value gets multiplied by A. The B value, okay, every X value gets divided by B or multiplied by 1 over B. Don't forget your reflections, okay? Negative values are reflections. Okay, and then the H moves your graph left, right. The K moves your graph up, down. And we can do all of those together and all at once. So anyways, here's your the first part of 1.3, and we'll take the second part tomorrow.